And if used properly, this is a game changer. It really is. So let me jump right into that. And I'm going to start by using it now. I want to make sure you can see my screen. It looks to me like you can. So I hope you had a chance to download this. I will be using this somewhat as a PowerPoint. Notice the title. It says Documenting Student Learning Using Classroom Assessment. And that's what we're going to talk about. Just to kind of talk to this issue, directly for a few minutes. Usually when it comes to a school or district or individual teacher, if you will, trying to document that their students have learned, we don't use classroom assessments. Almost never. And that's what we use is interim assessments. We use state level assessments at the end of the year for teacher evaluation with very fancy formulas, to look at student learning. And we're not saying get rid of those, but you can also use classroom assessments if you have the technology available to analyze that data properly and demonstrate the reliability, demonstrate the validity in a way that we would say rivals the accuracy of benchmark assessments, rivals the accuracy of state level assessments in terms of documenting how much students have learned. Rivals mean, it's right up there in terms of its precision and in terms of its validity, and doesn't cost a whole lot of money and actually measures what students are being taught in the classroom. So the reason classroom assessments have typically not been used is people assume, well, they don't have high enough reliability and they don't have a high enough validity. And that's actually not true if they're used properly. And I'm going to demonstrate that to you. And I'm going to spend a little bit of time probably doing a little bit of damage to your confidence in how precise state level assessments are and benchmark assessments are. This paper, it's not a simple paper, it's a technical paper, actually not that technical. It's a straightforward paper on a very technical topic. If you want to get even more technical, then what we recommend is that you look at this book here. It's Making Classroom Assessments Reliable and Valid. And if you actually read that book, all the formulas we're using here, they're all there. So this paper should get you in the door, to the place where you can actually use this and understand the logic behind on this. If you want to go in much more depth, then I recommend this this book. So let me start with some basic theory here. And if you're following me, go to page 13 in our PDF here. This formula, observed score equals true score plus error, this is the basic formula that all measurement uses. It really is. And this goes back over 100 years when it was really first developed. The idea is that the score that a student receives on any type of test is made up of two parts. One part is the true part, and the other part is the error part. Now, let me explain that. There's this notion of a true score, for a student whenever he or she takes a test. And the true score, it's got a mathematical definition. I'm not going to go into that now. You'll find that in that book I mentioned. But in general terms, the true score, it's a concept. It's like, under perfect conditions, where the test was designed perfectly and the student, perfectly attended to it and there were no distractions, what score would the student receive on this test? That's the true score. It's a construct, a hypothetical construct, and you can't observe that. But unfortunately, there always are distractions, or the test wasn't written quite well, or the test scorer, the teacher, gave points where he or she shouldn't, or took points away. That's called error. So that the score that a student receives, on a test, most probably has error in it. In other words, it's really not the true score. And so what measurement theory is always trying to do, and all these formulas that we use, is try to figure out, well, what is that true score? Or how this observed score, how close is that, to the true score? Now, that's where things get a little tricky, because if you look at the technical literature on testing, what you're going to find is testing experts will warn you about using a single score on a test to make a judgment about a student on any type of test. Let me illustrate that. This set of PowerPoints, first part here, is really a quotation from a gentleman named John Cizik. He's I've never met him. He's a straight psychometrician. And in 2007, he had a chapter in a book on formative assessment, oddly enough. And in that, he was making this very point. He was saying that, you got to watch out in terms of interpreting a single score for a student, because it's probably got a lot of error built in, error, E-R-R-O-R. And he used, as an example, a large Midwestern state's mathematics test. He didn't mention the state, which had it had a reliability of 0.87. Now, if you remember, reliabilities go from 0 to 1. 0 means scores are completely imprecise. They're all error. That never happens. 1.0 means they're perfect, and that never happens either. But reliability of 0.87 is pretty darn good. It really is. You'd say this is a great test, and I can interpret every student's score, now in a straightforward way, because this test has such a high reliability. Now, on the test, remember it's a state test, has or had subscales: estimation and mental computation, geometry, measurement, et cetera, et cetera. Each one of those has their own reliability. And those subscale reliabilities went from 0.33 to 0.57. Now, those aren't good reliabilities. Those are relatively low. It gets worse, okay? The real kicker here is that the reliability of different scores on this test is 0.015. That's 0.015. And here's, now they don't report, the test doesn't report a different score, but here's what a different score is. When a teacher or administrator looks at the test and says, I'm gonna figure out what to do with Bobby Marzano here in mathematics based on how well he did in this test, and he got the lowest score in geometry, that's where we're gonna start. Now, according to Cizik, doing that gets you in trouble right away, because there's so much error, in looking at different scores. It is a different score. You're saying that's the lowest score. I better do something there. Here's a quote from Cizik. It's a long quote, but it's really worth reading. I'll give you a second to read that. Pretty powerful. Can you see what he's saying? Making a decision about Bobby, on what to do next in mathematics based on that single score on a state test, subscale score, is tantamount to flipping a coin and saying, heads I do this, tails I do this. Now, that is kind of scary when you think about it. It really is. Just how how unreliable, why can't I get out of this? There it is. Okay. Just how unreliable a score on a state test can be for an individual student. You see, the traditional concepts of reliability don't apply to single student scores. They only apply to groups of scores. The way you can interpret a single student score is compute what's called a confidence interval around their score. And let's play with that a little bit. If you go to page 14, little demonstration for us here. This is a hypothetical situation. Let's say, look at where it says observed score, that column. You have a single student, he got a 75. Let's make it me again. Bobby got a 75. But this is a 75 across the tests with different levels of reliability. Let's say that I got a 75 on a test that had a reliability of 0.85. Again, pretty high. Now, you can, using simple mathematical formulas to be found in that book that I mentioned, you can compute a confidence interval around that score, a band of scores in which you can say, gee, I'm 95% sure the true score probably falls within this range. So look at what I've got here. I got a 75, even with the test that has a reliability of 0.85. The range of scores in which I'm 95% sure the true score falls go from 69 to 81. Let me say that again. The range of scores go from 69 to be 80 to 81. So to be 95% sure I've got a range in which the true score falls, I got to think it could be a 69, it could be an 81. That's a 12-point range. Let's go down a little bit. Suppose the test had a reliability of 0.55. Now that range goes from 64 to 86, a 22-point range. So the whole point here is that they're just not designed. Individual tests, even with high reliabilities, aren't designed to make a determination about an individual student. Well, what do these reliability coefficients mean? They were actually designed to talk about patterns of scores instead of individual student scores. Go to the next page. Let me show you. Now, literally, these concepts go back over 100 years, and we just don't use them, at the K through 12 level. Here's what a reliability actually tells you. It tells you how confident you are the pattern of scores over a group of students would be similar or different if you, gave the same test to the same students. That sounds kind of crazy, but actually, here's the theory behind it. Let's take this example here, figure 7. Got 10 students, and they take the test that's been designed. First student gets a 97, second student gets a 92, third student 86, so on and so forth. Now, I don't know how many of you have seen Men in Black, one of my favorite movies. Do you remember Will Smith, and he had the little gadget, the little clicker? Okay, now pretend the students took the test, and then Will Smith came in, and he got a little clicker, the flashlight, and he says, now they've completely forgotten, gives them exactly the same test. Okay, now they take it again, and this time their scores are not exactly the same, but they're similar. First student got a 97, first administration, next student a 98, 92, and then a 90. The correlation between those two sets of scores is actually the technical definition of reliability. And that's a high correlation. In this case, is 0.96. So these are highly related, but it doesn't tell you much about an individual student. It tells you about the pattern of scores. Now, I'll give you a different situation here. Initial administration, Will Smith then used a little clicker. He gave it to the students again. And this time, student number 1 got an 82 instead of a 97. Student number 2, an 84 in terms of a 92. The correlation between those two is a 0.32. That's a very low reliability. So reliabilities, as reported on tests, just tell you about patterns of scores across students, not individual student scores. If you think that I'm making up this ridiculous example, I'm not. Lee Cronbach and Richard Shabelson actually are just recognized experts in measurement theory. And this is a quote from one of their books. If hypothetically we could apply the instrument twice, and in the second occasion have the person unchanged and without memory of his first administration experience, then the consistency of the two identical measures would indicate the uncertainty due to measurement error. In other words, it would be the reliability. That is actually the model that test experts use, when they're computing reliabilities. So all this boils down to, if you're looking at an individual student score, you're not going to be able to tell much. It just tells you about patterns of score. So how do we get to the place where we can actually be confident that an individual student scores, I should say, are reliable and valid indicators of how well where the student is now and how much they've learned? Well, to do that, you first have to start with a good definition or identification of the content, that you want the test to cover. Oops, let me go to page, I believe it's 14. Page 14, no, darn it. Here. Just talk amongst yourselves for a second. I've got the wrong number here. The way you first start is to create a proficiency scale for the content that you are going to use to measure students' student growth. I apologize for this. I copied down the wrong number. Oh, this was not supposed to happen. Now, if you know my work at all, the term proficiency scale should be familiar to you. Instead of just identifying like essential learnings, we say you should actually create a continuum of knowledge. I'm looking for my proficiency scale. I think I'm getting close. There we go. We'll get to it. Sorry, I was going the wrong way. And a proficiency scale is just the identification starts with identifying what you want students to know and be able to do. So we have a scale that goes from 0 through 4 with half-point scores, but it really only has 3 levels of content. Here's the 3, and that's the target. That's what we're shooting for. In this case, this is elementary mathematics. Round a given number to the nearest nearest equation, or for example, round. Sorry, typo in there. Score 2 is the simpler content. Recognize certain vocabulary, basic processes, and the score 4 represents demonstration that students have gone above and beyond the target concept. Now, it's only got 3 levels of content, but you can actually assign 9 different scores. 3.0 means they've got the target content. 2.5 means they don't have all the target content, but they've got the simpler content at the 2 level and some of the 3.0 content. You get the idea. Now, if you do that for a unit of instruction on a particular topic, and then you create a test to be given as a pre-test and a test to be given as a post-test, then you've got a situation where you've got a test, 2 tests measuring the same topic. In this case, the topic's elementary mathematics. And if you have those scored by more than one person, you will have a beginning and ending point for the student growth that is rigorous. See, if I score my own tests that I create, there's an opportunity for bias. I might, give students points they don't deserve. But if I do it and along with another teacher or other teachers, you will create a beginning point and an ending point. You can say, wait a minute, these scores are rigorous scores, and you can compute the reliability of that. A lot of different ways of going about that. What some people recommend is that you get, if I have 3 teachers score the test, and I have 3 different scores for the students, you average those scores. For the pre-test score becomes an average, and the post-test score. It cuts out a lot of that error due to the bias, by an individual teachers. Okay, so we have a beginning point and we have an ending point. Now, that's critical. That is rigorous. It's not just designed by a teacher. Best if it's done in PLCs, and within a PLC, it could be scored too. You've got a good beginning point and a good ending point. Now, you could stop right there, but we recommend that using other types of assessments, which would be traditional tests, essay, performance tasks, probing discussions, student-centered assessments, voting techniques, observations, that teachers also enter other scores, for each student in a class. Now, the traditional tests would be, your traditional multiple choice items, short constructed response, extended constructed response, and those are typically the types of items that are used on the pre-test and the post-test. But in the interim, teachers assign scores to students using other types of tests. There's a key point here. In this system, not every student gets every test. Let me explain this using figure 5 here. Just take a look. I got 5 students 1 through 5. All of them took the same pre-test and all of them took the same post-test. And this represents days at the top. First day, second day, third day, fourth day, fifth day, all the way over 20 days. And that's kind of a good period of time to get a student learning on this particular topic in elementary mathematics. So a student number 1 got a 1.0 on the pretest, student number 2, 1.5, so on and so forth. Here's the post-test that was scored by more than one teacher. Now notice what happened. Student number 1 on day 5, the teacher entered another score for that student only. It might have been what we call a probing discussion, where the teacher sat down, and talked to the students. Very nice. Went over and put in 1.5. On days 7, 8, 9, and 10, no scores were added. On day 11, maybe the teacher gave another test, teacher design test. All students were scored. So you don't have to have every student. It's not the case. Every student has to be scored on every type of assessment that's given. General rule you can follow here is the less certain you are about a student's status, the more assessment you should give. And the more certain you are, the less assessment you can give. Now, how does this all get down to the place, we can ensure a high reliability and validity? The method that's used here, and this is where you need the technology, is as data is entered, it is analyzed using 3 different trend lines. Now, this is built right into the system. This is what you're going to see here in a bit. This is built right into the system. If you're an Empower user, this is actually built into the system right now. The bar graphs represent the observed scores for a particular student. In this case, there were 6 scores. Let's say this is me again, this is Bobby. I got a 1.5 in the first test. On the second test, I got a 2.0, third test a 2.0, then a 2.5, and then a 3, and then a 4. Okay, now those are the observed scores. The mathematical models can help us interpret, well, there's error in each one of those, so how do we, what's the true score for Bobby? How did he do? How did he do in each one of those? What were the true score for each one? And how much gain was there in his learning? That's what these lines tell you. And the system will look at, analyze the data in 3 different ways. One will be the average. And you could say, well, gee, if I take the average, I'm saying the true score for Bobby across this is 2.5. See, the average doesn't account for learning. I can use what's called the linear trend, and that assumes that learning occurs at an equal rate. Bob learned the same amount from week 1 to week 2 as week 2 to week 3. Okay, and that linear trend says Bob's true score at the end is 3.66, or the curvilinear trend. And that works under the assumption that Bob learns a lot, students learn a lot in the beginning, and then their learning tends to flatten out. So you will get this automatically. Scott's going to show you that's automatically reported. So at one level, the system, the tool that you have will tell you the true score as estimated, using those 3 models across all of those, every one of those scores. So this is the same thing. But what you will get in the system is it'll say, if we use the linear trend, it's saying that the final true score was 3.66. The one that before that was 3.19, so on and so forth. It will do the same thing for the curvilinear trend. It's giving you different estimates. And the average, it's the average is just a straight line. Now, how do you find out what's the best? What's the best true score for an individual student? And it'll do that for you too. The system will look at which of those 3 trends actually was closest to the observed scores. You see, here's the curvilinear trend. Here were the observed scores, but boy, there was a real difference in the mathematical estimation here with the curvilinear and the actual observed scores. Same thing with this. Not as much different. It will look at these and say, boy, the estimate that is closest to the individual's observed scores is the linear trend, or it's the curvilinear trend, or it's the average. That analysis will tell you the mathematically most rigorous estimate of the student's final score at any point in time. Now, Scott will go into this. You get a printout like this for each student. At the click of a button, it tells you how much error there was for each of the trends, curvilinear, average. Here were the 5, 6 scores. Here were the observed scores, the predicted score for each one, curvilinear. So at one level, you've got a tool that can be used, for each student. across the scores they received on a unit, it'll tell you this is the most precise mathematical estimate at the end of that set of scores of where the student is right now. So you get the most accurate estimate of a student summative score. So for one student, that trend, the best one might be the linear trend. That's what you use. Another student might be the curvilinear trend. Another student might be the average. And that occurs if they were high and then low and then middle. Mathematics say that they're all over the place. So the best estimate here is the average. That's all computed for you. Now, let's go to growth. That's a whole different animal. Now what we're looking at is how much did the class on the average grow? See, we can look at individual students, their growth. This is using the linear trend. I use the linear trend for this student. Student went from a 2.62 to 3.2. I can't read that. That would be the growth based on the linear trend. We can do the same thing for the curvilinear trend, et cetera, et cetera. Now, the powerful part about the tool is that it will look at three types of growth. It'll look at the growth based on the linear trend, the curvilinear trend, and just the observed scores. That's the last score minus the first score. But you can see, you can get strange patterns will give you strange growth scores. This student had a high of 3.5. His last score was 3.0. And his or her first score was 2.5. If you just use the difference between the last and first, it just looks like a growth of a half point. If maybe you computed on the trends, you'd see a different a growth score for that student. So what the system will do is look at the reliability of those three different types of growth. The curvilinear growth. Now remember, this type of reliability is the patterns. The patterns of all the students, you're looking at the students as a group, and it'll say, gee, the pattern of students using the linear trend has this reliability, using the curvilinear trend has a different reliability, and using the observed scores has a different reliability. You can even do that across classes. Let me set this up. Let's say that you wanted to use this for SLOs for teachers, or you wanted to use it for teacher evaluation as one other metric of how much their students have learned. And now we have 5 teachers, class 1, 2, 3, 4, 5, and these are all 5th grade mathematics teachers, and they're going to be teaching the same unit, using the same pre-test, and going to be using the same post-test. Pre-test is given about the same time for all classes. Post-test is given. The pre and post tests are scored by multiple teachers. Teachers can now enter scores on their own in between. The tool analyzes this for you. But then at the end, it says, okay, for the class number 1, the linear growth was 0.76. It had a 0.76 reliability. Different score, only a 0.42. Curvilinear growth, 0.84. So class 1, curvilinear growth is the most reliable. So we're looking at a group of students that's the one that's going to tell us the most. Now it can also put all of those together. You can put all 5 classes together and it will give you a reliability of all students, all put together. Now with that, you now have the metrics which tell you how reliable the growth scores are. And tell you the model that's best used for the growth scores for patterns of students, but you also have for each student, the mathematically most rigorous estimate of each student's final summative score and also where they started. And that's a lot, but I want to get, so if you, like I say, you can look at this paper, you can read the book if you really want to get into it. We will also work with you too if you're interested in that. But I want to make sure we have time for the tool. So Scott, I hope I didn't gum that up too much for you, but Scott, would you please take us through?
I'm glad to. So in the chat right now, I'm putting a link into the free tool. This is the Marzano calculator. And I will give us a demo going through this tool. Okay. All right. So when you click on the that link, you'll come to our login page. And if you don't have a login, it's very easy. All you have to do is just click this create a free account. just asking you for a name, a few pieces of information, and then you'll be able to log in. And so let's go ahead and see what happens once we log in. Okay, so I'm in the tool, and just to get a little bit of orientation, what I want you to notice right here is we've got a quick tutorial and guide, which takes us right directly to where we were earlier today. You can see also a video that's a tutorial that will go over maybe even a little bit more depth than what we're going to do today as far as how the actual tool works. And then here's again the white paper that Bob has been using and bringing us through. Well, the first thing that we're going to want to do is we want to create ourselves an opportunity to gather scoring. And we call this a score sheet. And what we're going to do is we're going to focus on a particular skill. Now, the power of this is to find out the true growth is we want to be able to focus on one skill. Like Bob was showing earlier, you could have an assessment that addresses 5 different skills in it. But if you only ended up with one score out of that assessment, you're not going to know, if they've got strengths or needs on which individual standards. So we're going to focus on just one skill, and I'm just going to do just making up something. Place value rounding. Let's say that was the skill we were going to focus on. Now, we're going to have what we're going to be doing is collecting scores over time. And so this just says, well, hey, what start date would you like to use, and how long are you going to provide this learning opportunity. And it can be totally variable, but this is just to create our basically our grade book. That's going to create a grade book for us. So I'm just going to keep this. I'm going to hit save. And we're going to come back to something really important here in a little bit, that I can share this sheet amongst other teachers, and we can all work together, have our own independent grade books for place value rounding, but it can aggregate the data and show, like Bob was showing, across classes, what is the growth, what's the reliability, all those great things. But for right now, we're just going to focus on just one sheet. So for instance, I'm probably a teacher, and I'm going to go in, and I've got the start of a grade book. I've got my students' names I can put down here, and I can just simply put in, change my names. Let's say this is going to be Bob. Scott. Sarah, so on and so forth. I can add new students, Jimmy, if I've got more or whatever. And so, so I have a list of students that I'm going to be scoring. I have my dates. Now, here are the test reliabilities, and Bob was telling us there is a pre and post test, and these are the reliabilities that we would put in. Bob, do you want to mention something about these right here?
Yeah, you need those. You need to estimate the pre-post test reliabilities. There are many ways of doing that. For default values, if an individual teacher is doing it, typically individual teacher test reliabilities are around about 0.55. If you create the test in a PLC, you get about a 0.75. A better procedure is to actually compute those reliabilities using the formulas that are out there. We'll do that with you if you want. Like, just if you have 3 people score a test independently, you just look at the inter-rater agreement, and use that as an estimate of your reliabilities. You need that for the difference score, the observed post-test minus the observed pre-test. You don't need that for the linear and curvilinear trends.
Okay, good. So important components here. Now, once we have that, we're just simply logged in scores. And you can see here, I've got a little scroll bar, and I have dates going across here. So what I'm going to do is just enter in scores as we have observed them. And let's say at the beginning here in the pretest, Bob got a 1, And this, you just kind of go through and enter in your scores, whatever they might be. Now, as time goes on, we're going to be gathering more evidence. And remember, the evidence doesn't necessarily have to be a formal assessment. It could be, you know, an activity, all kinds of events could qualify as a scoring event that we want to put down on here. And Bob, anything you would want to add to that as far as what we might use to classify, you know, data that should go in here?
Well, again, if you take a look at the paper of that book, you know, we talk about, you know, they're all different types, like say an observation of the student, discussion with the student, a activity that they completed that you looked at, student generated assessment where they say, let me prove to you I'm a 3, all those apply. And you do not have to have the same number of assessments per each student. That's a critical point. It really is. That the more confident you are about student scores, the less you assess, the less confident, the more you assess. Scott, that's kind of small. If we can, when you get it in, if we can get a little bigger.
Oh, I'm sorry. Sure. There we go. Okay, so again, so what we're going to do is over time, we would be gathering these scores. And you notice as I'm gathering the scores, all the stuff that Bob was telling us earlier, it's automatically calculating. It's letting us know what it believes the true score is, or the best fit. That's in green. But it shows us from 3 different approaches, 3 different predictions that we could have made.
Can you make that a little bit bigger? Can you make that a little bigger too, Scott? Yeah, this is critical.
I don't think I can, Bob. Is yours full screen? Are you using full screen on yours?
I believe I am. Yeah.
Okay, sorry.
Can I just point out that if you look at that for each student, I'm going a little blind here too in my old age. Yeah, with Bob, there's enough scores now that you can see it's, that's better. You can see there's my average score is 2.0. My linear, with the linear function, what does that say, Scott? 3?
3? Mm-hmm.
Yeah. And the power, it's 2.93. Those are immediately computed, you know. So I would say this is like an app. As you're entering scores, you know, the mathematical models are immediately being applied. And I'm a teacher and I say, well, wait a minute, let me look at those patterns. What's the best summative score there? Well, I immediately look at that, and it was a linear one that was lit up. That tells me, hey, mathematically, you know, true score is somewhere around there. Now you just clicked on the
precision.
Yeah, the precision. Now this is very detailed. You know, this gets into, for each predicted score, how close was it to the observed score? You know, we didn't have time to go into that, but that's automatic. It brings classroom assessment to a level of rigor that we've never had before, and you cannot do without technology. You just can't do it with technology. I'm just entering scores, and I understand the system. You know, it's being done for me. Go ahead, Scott. I'm sorry.
Yeah, no worries. And so some of the visuals that Bob had in the book, you have also, you know, it automatically creates for you here, where you can see the precision table, which is the, remember, each model has a predicted score it would expect. And it shows you what the prediction is, the delta between the observed and the predicted. And remember, the model where the student is behaving closest to the predicted is where we're getting the you know, the best fit. And so this just kind of outlines all that data for you. You can also see it charted with the different pieces for the, in this case, we had three evidences that we have entered in. Okay. All right. So so that is pretty simple exercise, right? So over time, we're gathering our scores, and we can go to the final tab, which is a reliability. And based on what we have entered in for the score, or you know, the data that we have, this is the kind of the overall output. And Bob, I'll let you explain this because you can tie it in a lot better than
I cannot read it though, Scott. I'm
oh,
sorry.
golly, I'm sorry.
I, I'm going, I'm going blind.
Okay, that's as big as I can get it, I think.
Yeah, yeah. So remember for the individual students, we were looking at for that student, what is the best final summative score? Okay, but now we're looking across the class. We're saying, gee, how much did the class grow? Okay, so remember that just like traditional reliability, I said, you know, the traditional reliability coefficient does not tell you about individual students. It tells you about a pattern score. Same thing here, but now we're talking about a pattern of growth scores. And this is, and now we got a problem here. We only had 3 students, you know, no matter what reliability equation you're using, you have to have at least about 15 students before it makes sense. But anyway, so you have to take these numbers with a grain of salt. So it is recommending to us, so what's it given? Observed score, class reliability was 0.567. For the curvilinear score, it says not valid. That's because there just wasn't enough scores, you know, with only 3 students. The linear reliability had a reliability 0.224. So it says if we're going to look at growth, what we should look at is observed growth. And that doesn't have a high reliability, but it's the highest of the group. Now, if you know, and these reliabilities are low simply because there are so few students. But now imagine doing this with a class of 30 students. You know, now for each student, you're going to be able to say with some precision, you know, a precision that rivals what you get on a subscale score of a state test or an interim assessment. You're going to be able to say, hey, here's the student's score on this particular topic, you know, and here's their growth on that topic, you know, with a lot of confidence. And if you want to say, how about the growth of my class? You'll be able to say that too. Now, Scott's only showing you 1 class. If you had 5 classes all working on this particular topic for which you created a proficiency scale, had a pre-test, had a post-test, had them scored by more than one person, now you can say with confidence, and here's the growth of each individual class, you know, and here's the reliability of that growth. Now, I'm sure you know what SLOs are. You know, the SLOs, student learning outcomes, that's a metric that's used across the country to come up with a way of teachers being able to demonstrate how much their students have learned. You know, well, this is a setup for SLOs. The SLOs with a lot of rigor in them, though. And with teacher evaluation across the country, teachers have to demonstrate that, you know, their students have grown. And a lot of places just use the end of year state test. And I'm not saying we get rid of those things, you know, but the problem is that state test might not have covered the content that I covered in the class. Now you might say that's a curricular issue, Bob should have covered that, you know, but if I didn't cover that, my students' growth is as calculated by that end of year test, it's not going to be an accurate indication of how much my students learn. See, with this system, you can say, okay, 5th grade mathematics, we do teach rounding. It's a 3-week unit. We're going to have every teacher use the same pre-test, post-test scored by themselves and other people, enter other scores, and we'll have a system that allows us to show, here's the growth, here's the reliability of that growth, and for individual students, here's the mathematical estimate of the most precise score. That the paper, the subtitle was, you know, transformation in testing. That's exactly what this is. You know, now classroom assessments can be raised to a level of utility, you know, that interim assessments are used for, the end of state tests are. And we're not saying get rid of those. Just add this to the collection. Add this to the collection. And what's really nice is that the data is immediately available to you. You don't have to wait for 3 months. You know, you could really do this in the beginning of the year, you know, in a 3-week unit, and do it at the end of the year in another 3-week, and give teachers a chance to say, gee, you know, what I'm shooting for here in my SLO, I want a full point growth in a 3-week period of time for every one of my students. I want that to be the average growth. Now that's powerful. It really is.
Good.
Now, what Scott has created is that's a free tool. I mean, you can use that. You could use that tomorrow to do it for an entire state if you wanted to. It is a really, really powerful tool. Like I said, we tried to give you all the documentation in the paper. That's it's straightforward. It's not an easy read. The book is straightforward and a complex read. It really is, but it's a complex topic.
Okay. So Nathan asks in the chat, can you do class reliability in Empower if you're already an Empower district? Nathan, that is coming. And it's actually kind of low-hanging fruit, because all of this data that we're entering here that actually produces this report is all of what Empower already does and has been doing for years. The only thing that we've got to do is generate the report automatically within Empower. So that is coming. A non-committed timetable on our part is it's probably going to be before start of school next year. So there'll be a little lag. However, and remember, I preface that with a non-committed timetable. Right now, this tool is available right now. And what I want to do real quickly is show you how across multiple teachers, you can use this tool to gather larger data sets.
Can I add one thing, Scott? Yeah, but what already is in Empower is for each student, those 3 mathematical models.
That's true.
That's there. Every time you enter
and this is there. Right.
Evidence scores for students, you get that. And it'll tell you, here's the mathematically most rigorous estimate of the student. So that's there right now. What's not there is this function here, but it's all there. Go ahead, Scott.
Yeah, thanks, Bob. That's a very good point. So a lot of what you do see here is in there. And in fact, if you want, you can even use this process to help automate the overall scores within Empower. You can use these and pick out the best selections and stuff. Lots of choices, but it's still in an evolution to be able to generate the final reliability chart. What I want to show you now is how you can use this tool to, across multiple classes, gather data for a single topic. So remember, we're working with our place value here. And I'm going to reselect this and hit the little edit pencil. It brings up the sheet that we created or saw early on in order to create this. I'm bringing this back up because I want to re-highlight this section. This is, if I wanted to share this amongst multiple teachers, I'm going to give them this number. If you'd like to add users to share the sheet, have them enter the number below into the join group. So the number is 5213, 5213. And I'm going to log out of this account. I'm going to log into another account of mine. Okay, so this would be, for instance, one of your teachers would have signed up for one of these as well. And was that 5213? Let me go back. So here's that join group. This is what they would click on, join group. They would put in whatever the number of that sheet was, add it. It just tells me you just joined place value rounded group. Perfect. All right. And I might have already created another sheet that has the students I want to work with. So I'm just going to reuse students from another sheet that I have. And here we go. So here I am. I have the all of the same items that the author of the sheet created. That same reliabilities. I can't change those as I'm going to call myself in this case as the teacher. I'm a consumer of this particular grading sheet. I'm a participant. So some things I can't change. I can't change these. This would be the typically same pre and post test that all of the classes are going to use, right, Bob?
Yes, same pre-test, post test. If you want to compare student growth on a particular topic, same pre-test, same post-test, both those scored by multiple people.
Perfect. And then it's the same exercise. I'm just going to be entering in scores over time. And I'm just going to arbitrarily enter some stuff here. Just get try to make this quick, folks. I'm just going to make sure we get maybe a good sample of data here. Some variations in our patterns. Okay, great. So now when I look at the reliability, I'm going to see it because I'm the consumer or the participant. I'm not going to be able to see it for the entire group, but I do see, oops, it looks like my data was bad.
No, yeah, it's just too few.
Is it?
Yeah. I thought you had a sheet in there with a number of people. Yeah, for the pattern across students, if you're less than 10, it's going to give you funny numbers. For individual students, doesn't matter. You need at least 3 data points. I thought you had.
Okay.
Don't you have one already filled in? I thought you did.
Yeah, let's see. Area of triangle, maybe I do here. Well, at any rate, so the main thing is the exercise of it. You're going to put in more data, but as a participant to the sheet, I'm just going to see my class, and again, I can go in and I can see all of the data for each individual student. I can see their charts. I can see the precision table if I wanted to kind of get drill down into the particulars, and then the overview for the reliability of the class. Now, if I log back in as the author of the sheet, kind of like the admin or the leader, if you will, let's see what we get now that we've had a participant. Okay, I'm going to reselect that sheet, place value, and now when I go to reliability, I have it for each class that participated. So in this example, I was a participant, right? Remember the sheet that I created with this user, and then the other user that I had is also a participant. I get the individual reliabilities for each class and growth. So I get a growth here and the growth there for my individual classes, but on top, I get the combined growth, where it considers all the classes basically as a single data set, and I get this. And Bob, would you like to add something to that?
Yeah, you still don't have enough students, but what happens now is if you did have, 5, if an administrator wants to, well, how much are my students? So at the individual teacher levels, like in these 5 different classes, how much are students growing? And they're a 5th grade. But also I could say, hey, how about my 5th graders? What's the best estimate of all my 5th graders together? And for that reliability across students, the more students, the better. And let those formulas, just don't work when you're down, 10 students. They're made for, 50, 60, 70, 80 students. So when you combine classes, you get a much more stable pattern of scores, and the reliability will reflect that. Now, what I want to add is that the level of the reports that are provided from this, as I say, rival what you're going to get in a state test or a benchmark assessment. Remember what Cizik said about the state test, please, those subscale scores. He said, when you're looking at individual students, and you're trying to say, well, Bob did better in this than this, the reliability of that is basically 0. The reliability was 0.015. This is coming from teacher design tests in a classroom over a relatively short period of time. That's the part that's the revolution. It really is, or can be it's just completely, different. I mean, it allows classroom assessments to be used in a way that we just have never used them before. Sean, you were going to jump in?
Yeah, we've actually received a few questions over the Q&A and within the chat feature. So I wanted to pose a few of those to you
Sure.
during the last few moments that we have together today. So the first one says, I can really see the benefit of using this calculator. Based on what you are sharing, the best use of this tool would be for assessment data and not necessarily day-to-day evidence. Is that correct?
Well, that if you look at that one chart that I showed that had the beginning, in the end, and that different scores had different students had different number of assessments, that is day to day. That really is. So for me, if as long as you have that solid pre-test and that solid post-test on a day-to-day basis, if you make an observation of a student and you think that is a really, I feel this really that what Bob knows right now really it looks like a 2.5. Enter that data. Enter it. That doesn't mean that every piece of evidence you have to enter. But when a teacher says, I really, based on what I'm seeing here, I think 2.5, realizing that has error in it, and that's fine. It will be the analysis of those scores mathematically that tells us what was an overestimate and what was an underestimate. So you can't go to the other extreme and say every day I got to enter something. No, but I can use pre-test, post-test, and then things in between, some of which are formal assessments, and some of which are really just discussions with students. So it's a kind of it's an equivocal answer. It is kind of day to day, but it doesn't have to be every day.
Got it. We had a related question was, could you use this calculator to measure reliability of classroom assessments across a whole year, or would you just use this for individual assessments?
A reliability of assessments across the whole year. I don't quite get it. We're talking about it. It's supposed to be used with one topic.
Yeah, that's the key.
Yeah, that's the important part, for which you have a proficiency scale. Now, if that topic lasted a whole year and you had multiple data points, yeah, it could be used for that. But then I think you run into the same problem of, boy, it's a long time to collect the data. The way it was designed is to be able to pick up a single topic, which is probably going to be taught in a unit, and that's a legitimate interval of time. Hey, I started them here, I entered here, how well did they do? So I pick up growth in these intervals of time, and I could do it multiple times over the year. And like I say, for teacher SLOs, schools could start using it tomorrow, literally.
Sure. I think we have time for one more question. If we wanted to use the calculator with a group of teachers, could we get support for how to do that? And what would that look like?
You want me to answer? What here? The answer is yes. If we will be happy to work with you, you should talk to Sean about that. We would enter into a consulting relationship with you. We will help you design the assessments, set those up, set up how you score the assessments, how you compute reliability, blah, 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 how to enter the data, and even how to, take all that data and put it into a report. But that, would be a consulting relationship with you. Likewise, you could just do it all on your own. If you want to do a little bit of reading, and, like any brand new tool, it's going to be a little clunky in your head at first, but once you get it, you've got it. It's really a pretty straightforward thing. So the short answer is yes. We'd be happy with it.
And I was also just going to add some specificity to that there is information on our website that is also addresses what Bob just shared, of just outlining what that guidance and support could include. Of course, every time we consult with somebody, it's unique to their individual needs. So that would just be a conversation. So it might be a good time to wrap up. If you have questions about that or other topics, please reach out to me. My contact info is right there on the screen. And I am obviously on the contact page for the Empower website. So with that, Bob, Scott, thanks so much for walking through all the content on this exciting new free tool. And for everybody, thanks so much for joining us today. We appreciate it from Empower Learning.
Thanks, folks. Appreciate it.
Thanks, everybody.
All right. Take care.